So our last section this week we're going to look at is on parallel and perpendicular lines. So we're still going to write the equation of a line. Okay, so we're still going to do the same thing we were doing yesterday. It's just that I might now say, you know what, I want you to tell me another line that's parallel to this one. Or I might say, I want you to give me the equation of a line that's perpendicular to this one. Okay, and I'll give you a problem. All right, so what did we agree on that parallel lines meant? Two lines are parallel if what? They never touch. So what does that mean if two lines never touch? Think about describing it in terms of something we've been talking about this week, like slope. How would their slopes compare? They're what?
Different slopes.
So one would be steeper than the other or less steep? Because what would happen if you drew two lines and one was less steep than the other eventually? They would cross, right? Eventually. So,
The same line, though, different.
yeah. The slopes are the same. Exactly.
Oh, yeah, the one you said constant.
Okay, for two lines to be parallel, on the first line on your notes, you have to put down they have the same slope. Okay? Two lines are parallel if they have the same slope. Now, can anyone think of an example of two lines that have the same slope that are not parallel? That's where number 2 comes in. Yeah, when it's the same line. Okay? This, and let me go like this. Make a copy of it, and let's make it red. The red line and the black line are not parallel there. They have the same slope. But what we would have to do, okay, if this was our x and y axis, we have to have something different. What do you think has to be different? The y-intercept has to be different. Like that. Now one of them crosses here. One of them crosses here. Now they're parallel. Okay, so for two lines to be parallel, two things. Same slope, different y-intercept. Same slope, same intercept, same line. Okay? Two lines on top of each other are not considered parallel. Now, what about a vertical line? Vertical line is so steep it's not even a number. How do we describe the slope of a vertical line? Undefined. All right, so that's a little different. Okay, vertical lines are so steep they're undefined. So vertical lines are kind of a special case. Okay, all you have to know about vertical lines. Okay, and on your notes there's a little star. Next to that star, put vertical lines are a special case. All vertical lines are parallel. As long as they're not the same line. This is not parallel to that. They're right on top of each other.
Why do I feel like this is reviewed?
You might have done this before. Sometimes you might have done a little bit of this last year.
I feel like it's reviewed.
But we haven't done parallel lines in this class yet. Yeah.
Maybe it was in Miss Lewis class.
Okay, I'm just going to add one thing right here. All vertical lines are parallel as long as they are not the same line. Okay, so a lot of times what I do first, if they give me a problem like you're going to do in example 1. Okay, let me get rid of that. They give me 3 different lines. Okay, it can be hard to tell from a picture if they're parallel. If I look at that picture really fast, they all look parallel. If I look at it closer, maybe I could tell one of them isn't. But the first thing that I like to do is find the slopes. Because line A, B, and C, very clearly, they already have different what? Yeah, line A, line B, and line C. They all meet that criteria. The y-intercepts are already different. I don't even know what it is. You know, this one looks like it's a little below -4. That one looks like it's a little before 1. And that one looks like it's 2 point something. It doesn't matter what it is. They're all different. So now what I need to do is check the slope of each line. Okay. If the lines are parallel, then the slopes are going to come out what? They're going to come out the same. All right, so let's look. Everybody have these two? All right.
There's one thing about that annoyed me so much.
So somebody tell me, how do you find slope? What is the formula for slope? Rise over run? Now, let's try writing rise over run. Now, if you have a picture, all you have to do is count. If you don't have a picture, what's the formula when you don't have a picture? Y, y2 minus y1 over x2 minus x1. Now, this time I have a picture. So, do I need this formula? No. Okay. This time I can just count. All right, let's, what line do you want to start with? Line A, B, or C?
A.
Line A. All right, line A. We need to find the slope. Okay, do you guys have this picture already on your notes? Okay, so between
I just feel like they still just got really
these two dots, go like this. Put a dot kind of going down, and then going over. Right, so Emma, explain to me what I do from there.
Okay. So then you take like the -1, because that's our
Negative what number? So we're looking at these points, right?
what? What do you have to say?
So what are we doing?
We're doing some stuff.
How do I do
Plugging
it?
it in.
Nope, we're not plugging in. What are we? Somebody help her out. What are we doing?
Yeah, what are we doing?
Line
Okay.
Are we-
I can do this on my own, but just not like.
Are we plugging into this? Okay, guys, be quiet, please. Are we plugging into this formula? No, we have a picture. So what did I say when you have a picture? Okay, use rise over run. Let's count. And we got to remember what happens with rise, and we should write this off to the side.
It is -1.
When you go up, is that positive or negative? Positive. How about when you go down? Negative. Okay, let's look at the run. There's two directions you can go for a run. What happens when you go to the right? What about when you go left? Negative. Okay, so keep those directions in mind. Let's start, doesn't matter which point you want to start at, the higher one or the lower one? Which one? Lowest. Okay, from the low point, what direction are we going to get up to the higher point? Left. How many units left? All right, we went left 5. So you know what I'll do? Let's just write that off to the side. Left 5. And then which way did we go?
right, up 1.
Up 1. All right, so now when I write this, rise over run.
1 over negative.
What was my rise here? Which one of these two numbers is my rise? 1, yeah. Up 1, that's my rise. And I should have asked, is rise, is up positive or negative? Emma, please stop talking. You are, thank you. Is up positive or negative? Positive. Okay. What about my run? It was left 5. Left is a negative. So what's my slope of line A? Yeah, you can write it as negative 1/5, or you can leave it just like that. This is fine. Now, does that by itself tell me if that line is parallel to line B? No. What do I have to find?
Line B.
What about it?
And line A.
Yeah, find the slope of line B. Okay? Let's go like this again. Draw your points. Yeah, this is correct. This is a negative slope because it slants down to the right. These are all negative slopes. Positive would look like that. It would slant up. All right, so line B, does it matter which red dot you start at? Nope. Let's start at this one. How many left do we go?
4.
So we go left. I'm just going to put this off to the side, and then we'll figure out what that means in a second. Left 4, and then up 1. Okay, what's my rise?
1.
Yep, I rose up 1. And what about my run? What tells you it's negative? It's slanting down. In what direction did we go? Left. Left is negative. That's the slope of line B. Close to line A, but not the same. So are line A and B parallel? Nope. Let's find, let's do my last line. Okay, as we go this way, and then this way. Let's do my run first. How many units did I move to the left? And because I moved 5, what direction is that? And that is a negative. Because we went left, and then we went up. How many? And up, should I put a negative in front of that? No, up is positive. That's the slope of line C. So now, out of those 3 lines, which ones are parallel? A and C. So in geometry, the way you write it is you can write A. That symbol right there means parallel, 2 bars that don't cross. If you don't want to write that symbol, just write it like this. Line A is parallel to line C. Okay, I like this, it's a little shorter. Okay, so I usually do that. And that's it. So line A is parallel to line C. Any questions on that? So the more lines you have, the longer it takes, because you have to find the slope of every one of them. You'll never have a problem where you have more than 2. Go down a little?
Yeah, what bulb is it?
Yep, this means that A is parallel to C. Okay, also when you do problems in the homework, that's how the lines are going to be labeled most of the time. A, B, and C. Obviously on the homework they're not going to be in color because the homework's just black and white.
I like commercial thing.
All right, so now the last thing we're going to look at is how do you find the equation of a line that's parallel to something? Okay, how do we do that? How do we find the equation of a line that's parallel to something else? We're going to use the same formula as yesterday. Okay, so in your box, somebody remind me, what's the formula we learned yesterday? Yep, Shannon?
Point slope.
Point slope. And can you tell me what it is?
It's y minus y1 equals m, and then in parentheses, x minus x1.
Perfect. Okay, so same formula as yesterday. So put that right in the box. M is the slope. Okay, you can already see that. Where did the x1 and the y1 come from? That's a what? That's a coordinate. Okay, so they'll give you a coordinate in the problem. Or a point. Okay, same thing as a coordinate. Okay, so you might have to put this outside the box if you don't have enough space. Just put it right below it. Now, in that formula, can somebody tell me what are the 3 things you have to plug in for? Just tell me one of them. Yep, Shannon, just give me one. Yep. I'm going to plug in something for that. Somebody tell me something else? Yep, Marissa? M. And what else do you have to plug in for? X1. Okay, and when we do it today, those are exactly the same 3 things you have to plug in for. All right, so the parts, right here where it says the same parts, you can almost copy and paste this from the notes from yesterday. Okay, there's only one thing that's different. What did we say about y yesterday? Stay the same or does it change? Stays the same. So y stays as y. If you want to write in parentheses, you're not plugging in anything for this, you can write that too. Okay, but all you really need to know is y stays as y. Don't change it. Now, does y1 stay as y1? No, it's one of, if I scroll back up, it's one of the things I circled. Everything I circled is going to change. Where do you get the number to plug in for y1? From the coordinate, from the given point. Okay, so look at the given point. The number that comes after the comma, that's the y1. That's exactly the same as yesterday. No difference right here from yesterday. Now, as you read across that equation, what's the next letter that we come across after the y1? M. That's the next one. All right, so where are we going to get M from? Okay, well, if you're writing an equation of a line that's parallel to something else, what did we just say parallel lines have? They have the same what? Yep. Slope. Okay, so for M, when they give you a problem, they're going to give you a slope. The slope, how do you know where the slope is? It's always the number attached to the x. So if you have an equation like this, okay, this is y-intercept form. But if they give you an equation like this, which they will, whatever number they put right here, that's the slope. It's the number attached to x. That's all you really need to know. It's the number attached to x. And the nice part is you just copy it. You keep it the same. Why? Because parallel lines have the same slope. So if I gave you this as a line, what's the slope of this line? Y equals 2x plus 3. The slope is 2. If I said to you, I want to know a line parallel to that, the line parallel to this would also have a slope of 2. It has to have the same slope to be parallel. Okay? So that's what I'm getting at. All you have to do is use the same slope as whatever they give you. Okay, x. That's the next letter you come across. Do we plug in anything for the x? Nope. Stays as x. That's all you need to know. X stays as x. Okay, and then copy down also x1. All right, so the x stays as x. And then the x1, well, where do you get the x1 from? The same place you get the y1 from. Look at the given coordinate. And it's the number before the comma. Okay, so the only thing that's different, and it's actually a little easier most of the time, is they're going to give you a number attached to x, so you're not going to have to find the slope. Okay? Maybe sometime you will, but in the first couple problems, you won't. Okay, in fact, yeah, towards the end, I think there is one problem. You have to find the slope on your own. Okay, does everybody have
Almost, I'm on.
Yeah. ground coordinates?
On the last.
Now, just like yesterday, if they say to find the equation of a line that's parallel, and they say to do it in point-slope form, you are done after that step. If they say to do slope-intercept, what are the 2 extra steps you have to do? What's the first extra step? Yeah? You have to use distributive. And then the second step, well, you're going to have a number right here. And we usually have to add it or subtract it to the other side. But that's only if they say do slope-intercept. Okay, maybe I'll just do one of those today, but everything else will just be point-slope. Okay, does everybody have what's on the board? Anybody still copying? Good? All right. All right, so this one says write an equation of the line that is going to pass through this point. So they're telling us a point, and they want it to be parallel to this line. Okay, so we have to find an equation that would go right through this point, and it's parallel to that line. All right, so, and they didn't say how to do it. They didn't say use point-slope form or slope-intercept. So maybe the first one, let's get it out of the way. On this one, we'll do it the long way, and then that's the only one we'll do the long way. All right, so, Bae, can you remind me, what's the formula for point-slope again? You just wrote it in the box on that other page. Y minus what?
Y minus y1.
Yep. Times x,
Yeah, minus x.
1. All right, so how many things do I have to plug in for there? 3. This, and that. So what I'm going to do, I want to make a list of those things. I need that. I need that. I need that. What is x1? What point did it say it has to go through for an x value? Okay? Yeah, what? 5. That value comes from the coordinate. Okay? What's the y value they said the point has to go through? -4. Now, they didn't tell me the slope, but they said the slope is parallel to this line. So if 2 lines are parallel, what's true about their slopes? They're the same. What's the slope of this line? 2. So what's going to be the slope of my parallel line? It's also 2. That's what I'm using for the slope. That's the only thing that's different from yesterday. You have to know the slope is 2. Any questions on that? That's it. All right. So now, can somebody tell me what my answer would be if I fill in those numbers? Yeah. Y. Now, what's going to happen when we do y minus -4? It's going to turn into plus. Okay? Y minus -4 is a plus. Yep. Yeah. Equals. Yep, we got a 2 and then our parentheses. X minus 5. Perfect. Okay. Off to the side, I just want you to write down what form is this? This is point slope. Let's practice changing it to slope intercept, because on the test, I'm definitely going to have you do that in a couple problems. Okay, Shannon just reminded us of the 2 steps. Okay, and I picked this one because you're not going to have any fractions. That's why I'm going to do it. Can somebody give me the first step to change this to slope intercept? Ashley? Distribute the 2. Okay, so distribute out my 2. On the left, keep it the same. How about, Antonio, what am I going to get on the right?
You should be 2 to that.
Yep. That's 2 times x.
Oh, 2x and then 10.
And positive 10 or negative 10?
Negative.
Right, because it's 2 times a negative 5. Don't forget, Mr. Roy, we always remind you, sign to the left goes with the number. Right? Negative 5. Okay, is that slope intercept? No, it's kind of nothing. Now it's in between point slope and slope intercept. So now we got to do one more thing to get it to slope intercept. Marissa? Subtract 4, subtract 4. Now once we finish it, that's slope intercept. Is the 2x going to change? No? What's negative 10 minus 4? Negative 14. And what do you call this? Slope intercept. Okay, these are both correct. This problem did not say which way to do it. So I did it both. This is the only problem today I'm going to do both. Okay, every other problem, we'll just stop right there. Okay. Any questions on how we did that? So we used our coordinate. We got the slope from the equation. And then we just plugged everything into the 3 spots. So we'll try, try this one. This time, leave it at point slope. You don't have to do the extra step at the end. Just stop. Start by making this list. And then after this one, we just have one more, and then we're all done for today. All right. So does anybody see any one of these 3 things and know what the number is going to be? Anyone think they know the x1? Liam? I like it. The x1 is negative 4. Maggie, how about the y1? Yeah, the y1 is going to be 2. Okay, the x and the y always come from the coordinate. And now they didn't give me the slope. Right? They didn't say the slope is this, but this is what they told me. My line is parallel to that one. So what does that mean if I compare the slope of my line to the slope of that line? The slopes are going to be the same. Do we know the slope of this line? Yeah. What is it? It's 1/4. So what's the slope of my line? So that's why I'm going to use the same thing. What if I use a slope other than 1/4? What would happen if you compare my line to that line? They wouldn't be parallel. Okay, I got to use the same slope. All right, so Nini, can you start us off? What's the point slope start off with? What letter? Y. And what comes after that? Minus. That's good. You stop there. Let's see. How about Trenton? I haven't heard from Trenton today. What comes after Y minus?
2.
2, right? Y minus Y1. Good. Kyle, what comes after the 2? Equals. That's good. Stop there. So we got equals. Natalie, what comes after the equals? Your slope. 1/4. Okay. Very important, but often forgot about symbol that comes after the 1/4. Parenthesis. You can't forget that. It's got to be there. Might as well put the other one in at the same time so you don't forget it. Hannah, what goes inside the parenthesis first? X. Perfect. I like it. Antonio, what comes after the X?
Minus the -4.
Minus, and then I was going to ask.
So it'll be +4.
Yep, it's going to be minus -4. So we'd be like that. Minus a minus, we'll just kind of turn it into a plus. And that is the final answer. What form is that in? Point slope. What's the name of the other one? Slope intercept. I'm not going to do slope intercept this time because now you've got a fraction. The answer would be a little messy. So we're not going to do it. Okay. Any question on that one? Question?
Yes. On the test, will you have one that's a little messy?
The numbers are going to work out pretty nice on the test. Yeah, you're not going to end up with weird fractions. Okay, if I had you convert something like this on the test to slope intercept, it would be more like this problem. No fractions. Okay? Or if it is a fraction, it'll come out very, very nice. All right. This problem, the last one, this is very similar to the first one. Okay, we have line A and we have line B. And the only question is line A parallel to line B? That's it. Yes or no? Okay, we just want to know if they're parallel. What makes this question a little harder than this question? You don't have what?
No graph.
Yeah, you don't have a graph. Okay, so you can't just easily count and do rise over run. So this is what we did last time. What are you going to have to do this time? The formula, you're going to have to do that. Okay, because you don't have a picture. Okay, so what I want to do is I'm just going to separate my work into 2 sections. I'm going to do everything for line A on one side, okay, and then I'll do line B on the other side, because we don't want to mix things up. Okay, can somebody give me the 2 coordinates for line A? How about Ashley? What are the 2 coordinates for line A? -5, 3. And the other one? -6, -1. Okay, now let's write down the 2 coordinates for line B. How about B? What's 1 coordinate for line B?
3,
Yep, and the other one?
2,
Perfect. Now, what are we going to do with each of these lines, or each of these points? What do I have to do? Yeah, let's start by finding the slope. So, before we find the slope, I want to ask one question. If they both come out to the same slope, does that automatically mean they're parallel?
No.
No, because what else has to happen to be parallel?
Different line.
Yes, they have to have different y-intercepts. Now, so if they have the same slope, then we have to check the y-intercept. But if they have different slopes, then do we have to go any further? No, if the slopes are different, they're not parallel. Okay, we're done. All right, so let's check it. Slope. Let's label, we got a lot of negatives, but there's not a lot we can do about that. Let's call that x1, y1, x2, y2. Okay, what goes on top? What minus what? Antonio?
Y2 minus Y1.
I like it. Y2 minus Y1. What goes on the bottom?
X2 next.
X2 minus, what's X1?
Is
Negative
negative 5.
5. Okay, first thing I'm going to do so I don't get confused. Minus a minus turns into what?
Plus.
So let's just make that a plus right now. All right. What's negative 1 take away 3? Negative 4. And what about negative 6? That's plus 5. Negative 1. So what is the slope? What's a negative divided by another negative? Positive. And the slope is 4. Could you also say 4 over 1? That's the same thing. Okay, I'm just going to say 4. All right, let's check this one. This time, because you don't have a graph, I decided just to make it 2 lines instead of 3, because it takes a little longer to do the formula. So you only have to check 2. Okay, you wouldn't have to check 3 by hand. X2, Y2. Okay, just labeled everything right in order. All right, somebody besides Antonio, can you tell me what goes in the top? Hey, just tell me the actual actual numbers. Yep. Negative 7, negative 2. Before we even do the bottom, what can I do in the top right away? Yeah, minus a minus. Let's just turn that into a plus right now. Okay. What goes in the bottom? Anybody know?
Positive
2,
3. Oh, no.
and then the positive 3. All right, what's negative 7 plus 2? Negative 5. And what's 2 take away 3? Negative 1. So what's the slope here? 5, right? Negative over negative is positive. So, do we have enough information to answer the question? Yeah. Are these lines parallel? Well, what's the slope of line A?
No, they're not.
4, what's the slope of line B? Are those different?
Yes.
They're not parallel.
They're not parallel.
Okay, how do you think you can write A is not parallel to B? Anyone think they know the symbol for not parallel?
Well, we don't have those things.
It's like it's almost common sense. I showed you parallel. What do you usually do when you want not? Put a line through it. Okay, that means A is not parallel to B. Okay, if you don't like the symbol, okay, you don't have to use it. You can just write the sentence, A is not parallel to B. Yep, that's it. All right, so any questions on parallel lines? Okay, what kind of lines are we going to look at tomorrow? Perpendicular. Okay. Okay, so okay guys, couple reminders. Eyes on the board. Eyes on the board. Tonight's homework, okay? 4.2 and 4.3 reference sheet. That's tomorrow night's homework. I'm going to put that on Google Classroom tomorrow. Okay, so bring your Chromebook tomorrow because what are you going to have to do at the end of class? You're going to have to print it. Our test this week. What day is the test? Look at the board. Thursday. What are we doing in class on Friday? We're going to review for midterm. When's our midterm? Thursday, January 26th.